Hello, David Snowpeck here from Snowpeck Games, and this is part 4 in a tutorial series about implementing rollback netcode in a game built with the Godot game engine. Last time, we talked about the sliding window technique and the MTU as they relate to quickly and reliably sending input. We created a custom message serializer for our demo game, and we looked at a more complex example from my Retro Tank Party game. However, our demo game is still pretty boring. At the end of part 3, you can just move a little Godot sprite around. Everything is syncing, of course, and doing rollbacks correctly, but there isn't much gameplay. In this part, we are going to add the ability to drop exploding bombs, and to do that, we're going to have to learn about spawning scenes and using timers with the Godot Rollback Netcode add-on. Let's start with timers. Godot's built-in timer nodes count time in seconds, which means they won't work for rollback netcode. We need them to be able to rewind when the game rolls back and to move forward multiple times within a single frame when we're resimulating ticks. And in order to do that, we're going to need a timer that counts ticks rather than seconds. The Godot Rollback Netcode add-on provides a NetworkTimer node that does just that. And it's not really special magic or anything. It's built on all the same stuff that we used for our player script back in part 2. It's in the network sync group. It has a network process method and save and load state methods. And that's all just to say that it's possible for you to implement your own rollback aware utility nodes. So anyway, we'll be using some network timers in our demo game. We're also going to need to spawn and despawn some scenes, which is a tricky problem in rollback, and let me show you why. Here is one of our familiar timelines. Let's say we spawn a scene on tick number 3 and despawn it on tick number 6. If we're on tick number 4 and roll back to tick number 2, we need to despawn the node, because when we're resimulating tick number 3, maybe the thing that caused this scene to get spawned in the first place won't happen this time. Maybe we predicted something incorrectly, and now that we have all of the real input, it will play out differently. Or, if we're on tick number 7 and we roll back to tick number 5, we need to respawn the node and put it back in the exact same state that it was in on tick number 5. Again, this is because when we resimulate tick number 6, maybe the thing that caused it to despawn won't happen this time. Or maybe it will, and the node will just be despawned again, and that's fine. The Godot Rollback Netcode add-on provides some APIs for spawning and despawning nodes, and if you use them, it will automatically handle the situations described here for you. But you may have also started to wonder about the performance of spawning and despawning lots of nodes during a rollback. The Godot Rollback Netcode add-on also has an optional pooling feature where it will hang on to despawned scenes and reuse them, which can provide a really big performance boost for games that spawn a ton of stuff. And we'll touch on all of these things in just a moment. Let's head over to the Godot editor. The first thing we're going to do is create a new 2D scene. Let's rename it Bomb. Add a sprite. You can get the PNG files for the sprites from the Git repo that I linked to earlier. I put them in the assets directory. Make sure to change the import preset to 2D pixel. Drag the bomb.png over to the texture for the sprite. I want to kind of center the sprite in the scene. Now let's add a network timer. Rename it to explosion timer. We'd like the bomb to explode after, say, 1 second. Our game simulation runs at 60 FPS, so let's change the wait ticks to 60. Now let's attach a script. Bomb.gd is fine. We'll delete all of this template stuff. And we need to implement a new virtual method related to scene spawning called network spawn, which takes a data dictionary. We pass in some data here to initialize the scene. All we need in this case is the position, and when we spawn, we want to start the explosion timer, which we need a reference to. There. And when the timer goes off, we want it to just despawn ourselves. So let's click on explosion timer, go over to node, double click on timeout, connect. And rather than calling queue_free like you might be used to, we're going to call sync manager despawn self. Now we need to set up our player to spawn some bombs. First, we need to pass in a new piece of input. when the player presses the UI accept action, which is just enter or space, we are going to set drop bomb on the input dictionary to true. And then we need to use that in our network process. If drop bomb is true, then we call sync manager spawn with the name of the node, an integer gets appended to prevent duplicates, the parent that we want to spawn the scene under, and the packed scene to instance, which we need a reference to. Let me put that up at the top. And the data, which gets passed to network spawn. Oh, and it's not finding because we haven't saved this scene. Let's save it real quick. And there we go. In the last part, we set up our message serializer, which we'll need to update for the new piece of input. This is a simple Boolean value, so we can put it in the header as a bit flag. We'll add the new bit flag drop bomb up here, and then in serialize input, when drop bomb is true, we set the header flag, and in unserialize input, when we see the bit flag in our header, we set input drop bomb to true. One last thing, we don't have our own custom prediction code. We're just using the built-in default, which is to duplicate the input from the previous frame and use it for the current frame. But with our new input, that isn't the best prediction anymore. Because we're using isActionJustPressed, it's most likely that if they dropped a bomb last frame, they are not dropping a bomb in the current frame, because it'd be real hard to press, release, and then press again a button within 16 milliseconds. So we add a new virtual method called predictRemoteInput to implement our own custom prediction code. It takes the previous input dictionary and the ticks since the last real input. We duplicate the previous input and then simply always erase the drop bomb key so that if it was present in the previous frame, it's not going to be present in the current frame. This prediction is still very simplistic, but it's better because we're taking into account the game's controls. Now, let's save it and try it. I'm going to start this game instance as the server and this one down here as the client. And once the match starts, I can move around my sprite and press the spacebar to drop bombs that disappear after a second. So that was pretty easy, right? Now let's talk a little bit about how this works. This data that we pass into sync manager spawn is stored in state. So if it needs to be respawned, it can use this data again. But you have to be careful about what you keep in state. We're going to talk about state at length in the next part, but one of the rules is that you can't put nodes into state. They can continue to change, which will change what is stored in state because nodes are passed by reference, and they can be destroyed and respawned, so the node that you put into state may no longer be valid. So usually, you actually want to put the node path or some other values from the node into state. Let's say we wanted to store the player that dropped the bomb, if we wanted to pass that to the bomb. We could do player equals self, but as we just discussed, that would be unsafe. So instead, we could actually do self.getPath. However, that's not necessarily the nicest API. It'd be much nicer to just pass in the player node and let the bomb script just take what it needs from it. So we have this other virtual method, networkSpawnPreProcess, that we can implement on the bomb script, which optionally can be used to take the data passed into network manager spawn, preprocess it before it'll get put into state and passed to the network spawn method. So we could process this data to set player path by getting it from the player node. So this is just a tool to give a little bit better developer experience to spawning our scenes. Another very important thing to be aware of is making sure that you're doing any extra setup on the spawned scene in a rollback safe way. For example, let's say you wanted to attach to a signal on the bomb that's emitted when it explodes. Well, Sync Manager Spawn actually returns the top-level node for the spawn scene, so you think it'd be okay to put something like var bomb equals syncmanager.spawn and then bomb.connect exploded self on bomb exploded, assuming bomb actually had an exploded signal. But this is a problem. If the bomb is respawned due to a rollback, this code, the bomb.connect, won't actually run. This only runs when the bomb is spawned with ticks executing sequentially, going forward normally. To ensure that this happens every time this scene is spawned, you need to connect to the sync manager scene spawn signal. So let's change this code back, and then let's implement the ready method, where we will connect to the scene spawn signal on the sync manager, like this. Then in our onSync manager scene spawned, we will check if the scene spawned name equals bomb. This is just the first argument that's being passed to sync manager spawn, and if so, we'll connect to the exploded signal. By the same token, if you need to clean up when a scene is despawned, for example, to disconnect from a signal, you need to do it in the scene despawn signal. That'd look like this. In our ready method, we'll also connect to the scene despawned signal on sync manager. And in our onSync manager scene despawned callback, we again check if the name of the scene equals bomb, and if so, we disconnect from the exploded signal on the despawned node. So both our setup and cleanup code will always be executed when the node is spawned, no matter how it's spawned, whether that's directly due to the sync manager spawn method being called, or in response to a rollback when the node is being respawned. And one final thing, as I mentioned earlier, there is built-in support for pooling and reusing old scenes rather than fully destroying and recreating them. If your game involves a lot of object spawning, especially with more than 2 players, it can get very expensive during a rollback to destroy a whole bunch of objects only to respawn the exact same objects again when the ticks are resimulated. This helped Retro Tank Party immensely because we're constantly spawning bullets. However, enabling this feature means that you, as a developer, will have to do a bunch of extra work. So I wouldn't recommend enabling this until you start having performance issues. But here is how you do that. Go to Project, Project Settings, scroll down to Network Rollback, and check the Reuse Despawned Nodes under the Spawn Manager section. Where the extra work comes in is that you need to implement a new virtual method, network despawn, on all of the scenes that you spawn. So that would be, in our example, the bomb script, and we'd have a companion method network despawn to go along with our network spawn. And it needs to return the scene roughly to its initial state so that when it's reused and network spawn is called again on the same node, that everything will work correctly. If you forget to reset something, it will lead to some weird bugs. So again, I don't recommend turning this on unless you really, really need it. Now for completeness, I want to see these bombs actually explode. So let's do one more thing real quick. We're going to add a new 2D scene, rename it to Explosion, add a sprite. We will drag over the explosion.png to the texture. We'll just use a single frame of animation because we are carefully avoiding using an animation player. We do have the network animation player node that's part of the Godot Rollback Netcode add-on, and it's rollback aware, but I have a whole bunch of things that I want to say about it, so we're going to save that for a future video. So for now, let's just drag the sprite up a little bit to kind of center it. We will add a network timer, rename it despawn timer. Let's set the wait ticks to 15, which is about 1/4 of a second, assuming rollbacks don't shorten your experience of it. We will save this scene as explosion.tscn, attach a script, and we're going to do a lot of the same things that we did in the bomb script. Copy and paste all of this code here, which grabs a reference to the despawn timer. Network spawn sets the position and starts the despawn timer, and then on the despawn timer timeout, we despawn ourselves, which of course we need to actually connect that. We'll go to the despawn timer node, double click on timeout, click connect, and we will see that it is now connected. Now we just need to go over to the bomb.gd and actually spawn these explosions. Let's preload the explosion scene. And when the explosion timer times out, we will first spawn an explosion, setting the position before we despawn ourselves. And that should be enough to make this work. Let's test it out. So I'll set this one up as the server, and this one as the client. And once it starts, I should be able to move around, drop bombs that spawn little explosions 60 ticks later. So that's all I have for today. I hope you enjoyed this tutorial. Please let me know if you have any questions. And next time we're going to talk about state, hashing, and mismatches. Talk to you then. Bye-bye.